Hey, geometry students, welcome back. In this video lesson, you're going to learn how to do some proofs and problem solving with auxiliary lines. This is bonus material that is not found in your textbook, but it is testable material. You will have proofs or problems with auxiliary lines on your exam, and it will show up on your final. So make sure you pay close attention. Okay, so I'm going to start off with an example of one of my favorite proofs that involves an auxiliary line. So sometimes it pays to use an auxiliary line. So an auxiliary line is simply a line that you add to a diagram without changing any of the other features of the diagram. Okay, and you're going to add a very specific line. So you're going to add a line sometimes inside of a shape or outside of a shape, but it has very specific features that'll help you solve a problem or help you to complete a proof. So we use auxiliary lines in strategic ways to help us complete proofs. One of the coolest proofs using an auxiliary line is actually used to prove the triangle sum theorem. This is one of my favorite proofs in geometry. So here we have a triangle ABC, and we have something called the triangle sum theorem. So the triangle sum theorem tells us that for any triangle, it doesn't matter the size or the shape of the triangle, okay, the triangle, the interior angles, this angle, this angle, and this angle, the sum of those three interior angles is always 180 degrees. And so to prove that, we use an auxiliary line. So what we do is we add an auxiliary line through point B, through vertex B, that is parallel to this opposite side, side AC. So something like that. Okay, and so these two are parallel. And then when we look at this diagram, we have two parallel lines cut by two transversals. And it just happens to be that these two transversals also intersect each other right at this parallel line, auxiliary line. Okay. But if you look at the angles, okay, this angle right here, this interior angle at A, and this exterior angle here, those are actually alternate interior angles. Okay, let me go back. Okay, these are alternate interior angles. If you just look at the two parallel lines cut by this transversal, these are AIAs, and so we know that AIAs are congruent. So this angle is congruent to that angle. And likewise on the other side, when we look at these two angles, angle C, this interior angle, this is congruent to this angle because those are AIAs as well. And then if you look at this angle right here, well, that is just angle B. So I'll put the B right there. So now when you look at these three angles, angle A, angle B, and angle C, well, they are a straight angle up here. And so we know that the measure of angle A plus the measure of angle B plus the measure of angle C is a straight angle, so it equals 180 degrees. And so we know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. You also have measure of angle A here, measure of angle B here, and measure of angle C here. So the interior angles of a triangle add up to 180 degrees. Okay, this is a little bit kind of a complex proof for what we've learned so far. So let's simplify this a little bit, and let's use auxiliary lines for what we've already learned. So this is the type of diagram that you're going to see where we're going to use auxiliary lines. So we have two parallel lines cut by, well, this is not really a transversal because this is a ray and this is a ray. Okay, and so it's an interesting point. You have this sort of, so this is two parallel lines cut by an angle, really. Okay, cut by this angle RTV. Okay, and this angle's vertex, I'm going to call that an inflection point. It's a point where this transversal kind of changes directions, right? So we're going to, anytime you have a diagram like this, and this is really just, to just, let the secret out, this is really the only type of diagram you're going to have to use auxiliary lines for. So anytime you see a diagram like this, you know you're going to have to use an auxiliary line. And the specific auxiliary line you're going to use is you're going to draw a line, just use your straight edge and your pencil and draw a line carefully through vertex T, through point T, that is parallel to these other two parallel lines. Okay, so add an auxiliary line right there. Then I went ahead and labeled this line AB. Okay, so now what do we know? Now, if we ignore the bottom part of this diagram, when we just look at the top part of this diagram, well, we just have two parallel lines cut by a transversal. And then likewise, if we ignore the top part of the diagram and just look at the bottom part of the diagram, here we have two parallel lines cut by a transversal. So those are in our wheelhouse. Those are in our comfort zone. We can do a lot of things with two parallel lines cut by a transversal. Okay, so let's look at the upper portion of this diagram and just block out this bottom part. And those of you that really struggle visually, because you're not the strongest visual learners, I would take a blank sheet of paper and just cover up this bottom part of the diagram. So then you're looking at a very familiar diagram of two parallel lines cut by a transversal. When you have two parallel lines cut by a transversal, we know that these two angles are going to be congruent. So since this is given to us as 60 degrees, we know that this is 60 degrees. How do we know? Because that angle pair relationship is AIAs. Those are alternate interiors. Okay. Likewise, on the bottom of this diagram, we have alternate interior angles right here and right here. So those are both going to measure 65 degrees. And then what we've been asked to do is to find the measure of angle RTV. RTV. So we know the segment addition postulate just tells us that this big angle RTV is made up of these two smaller angles. Okay, so if you just add 60 plus 65, you get 135 degrees. And so we know that the measure of angle RTV is 135 degrees. Pretty cool, huh? Here's another example. Okay, and so again, when you see a diagram like this, where you have two parallel lines cut by an angle, okay, you know that this is a case where we're going to add an auxiliary line right through this inflection point, the vertex 1. Okay, we're going to add an auxiliary line. We're given that lines P and Q are parallel. You can see these two parallel marks. Okay, and we're asked to find the measure of angle 1, this big obtuse angle right here. Okay, so go ahead and add your auxiliary line and pause the video and see if you can figure out what the measure of angle 1 is. Okay, so this diagram is very nice. It's very symmetric because you have 135 degrees here and 135 degrees there. Okay, corresponding angles theorem. These two are corresponding angles when you have two parallel lines cut by this one transversal. Okay, these are corresponding angles, so that's 135 degrees. Likewise, on this side of the diagram, here we have two parallel lines cut by this transversal. These two angles are corresponding, so you have 135 and 135. Okay. So what we really want to know is what is this angle and this angle? Well, these are linear pairs. These are linear pairs. Okay, so we know that those are 65 degrees and 65 degrees. And finally, go back and answer the question. The measure of angle 1 is 65 plus 65, or 130 degrees by the segment addition postulate. All right, so I thought this would be a good time to review because your next 4 lessons, there's no new teaching, there's no video lessons that I'm going to add to this. Basically, they're all review. They're just practicing proofs, okay? So remember your basic strategies for proofs, especially when you're doing proofs with two parallel lines cut by a transversal. You always want to link those two angles to a third angle, okay? Find a third common angle, whether you're doing the hashtag proof, the bow tie proof, just straight up two parallel lines cut by a transversal. It does not matter how complex the diagram gets. You're going to use those 4 theorems with two parallel lines cut by a transversal: corresponding angles theorem, AIA, AEA, and CIA. Okay, and link the two angles that you're going towards, that it's asking you to prove something about. Link those to a third angle. Make sure you use the strategy of marking up the diagram as you go. Okay, a lot of times if people get stuck, when students get stuck in the middle of a proof and they don't know where to go next, it's because they haven't marked the diagram. So every time you make a statement and prove a statement, make sure that you mark that if it's not already marked by the authors on the diagram. Then when you get stuck in the middle of a proof, simply look at your diagram and the markings will kind of give you a clue as to which direction to go next. Finally, another strategy that we just learned is use an auxiliary line if necessary. And remember, the auxiliary line proofs and auxiliary line problems always look the same. It looks like two parallel lines cut by an angle. Or sometimes it might be more than, it might be three parallel lines cut by an angle. Okay. All right. So let's go ahead and do this example. So this is a pretty complex example, not only because the thinking behind the proof is not any more complex or any different than any of the other proofs. It's pretty simple. Normally just kind of a four-step proof. But because we're asked to prove supplementariness, okay, I want you to pay very close attention to the conventions and the statements that I go through. Because we're proving supplementariness and we're not proving congruence, there's a couple additional steps that we have to do. We have to go from supplementary to measures equaling 180, and then from measures equaling 180 back to supplementary. I'll show you what I mean in just a moment. So we're given that these two magenta lines are parallel. M is parallel to N. We're asked to prove that angle 3 and angle 8 are supplementary. Here's 3, here's 8. Now, when you have two parallel lines cut by a transversal, I taught you a shortcut to remember. The shortcut was that the four acute angles are all congruent and the four obtuse angles are all congruent. Okay. But if you're looking for a combination of one acute angle, which is this is an acute angle, and one obtuse angle, those are always going to be supplementary. Okay. So how do you prove this? Well, 3 and 8 do not have an angle pair relationship name, right? Those are not corresponding. They're not CIAs. They're not any of those. Okay. So we have to use the strategy of linking those two angles through a third angle. Now, there's more than one correct way to do this. Okay. You could link 3 to 2 and 2 to 7 and 7 to 8, or you could link 3 to 7 and 7 to 8, or you could link 3 to 5 and 5 to 8, or 3 to 4 and 4 to, you can do this many different ways. Okay. What I chose to do was I chose to link angles 3 and angle 8 to angle 6. Okay. I happen to like AIAs. I think AIAs are something that students just naturally see very easily. And so I used angle 6. Okay. But you didn't have to. Okay. So I went ahead and I made a mistake here. Number one, I should have written the given. I forgot to write the given. My mistake, my bad. Okay. So up above here, we'll write 0.5 M parallel to N, 0.5 given. Okay. Go ahead and add that into your notes. Okay. I was so eager to jump into the proof. Okay. So my next line, okay, line 1, which should have been line 2, but okay, I'll just go ahead and call it line 1. I went ahead and linked angle 3 to angle 6. So what's the relationship between 3 and 6? Those are AIAs. Okay, those are AIAs. So we know because these two lines are parallel, we know that AIAs are congruent. So angle 3 is congruent to angle 6. Okay. Now I have to go from congruence to equality, and you'll see why in a moment. So let's go from congruence to equality. So we go from angle 3 congruent to angle 6. The next step is going to be that the measure of angle 3 is equal to the measure of angle 6, and that is definition of congruence. Remember, anytime you're going straight from congruence to equality or equality to congruence, that's the definition of congruence, okay? So why did we have to turn this congruence statement into an equation? Why did we have to turn these shapes into numbers? Okay, you're going to see in just a moment, but long story short, I'll just jump to the punchline, okay? Because there is a substitution property of equality, but there is no substitution property of congruence. You can't just substitute things that are congruent, okay? Anyways, here we go. Step 3. So now that we've linked the relationship between 3 and 6, let's go ahead and look at 6 and 8. Well, 6 and 8 are supplementary. How do we know they're supplementary? Because of the LPP, the linear pair postulate. 6 and 8 are linear pairs. And so linear pairs gives us supplementariness. Okay, be careful with this step. Okay, one common student error is students will automatically go to measure of angle 8 plus measure of angle 6 equals 180 degrees. That is not what the linear pair postulate gives us. Linear pair postulate gives us supplementariness. Then supplementariness then allows us to conclude 180 degrees. Okay, so here's the next step. So because these two angles are supplementary, therefore we know that their measures add up to 180 degrees. That is the definition of supplementary angles. Now you're seeing why I chose this proof instead of just a straight up congruence proof. So now let's look at this statement. Now we have an equation. We have some value or some number plus another number equals this number. Okay, we have an equation. Here we also have an equation. So we can substitute one of these values into this equation. Well, here's measure of angle 6, here's measure of angle 6. So we can drop this, and in its place, we can put this in, measure of angle 3 right in there. And what allows us to do that is the substitution property of equality. Okay, we couldn't do this if we didn't go to this step. If we just left this as these two angles are congruent, we could not substitute this in there. It doesn't work that way. So this is the substitution. Remember, POE stands for property of equality. And remember, the convention that I like to see is 2, 4. We're substituting a value from line 2 into line 4. Okay. Now that we have that these two angles, 8 and 3, their sums, their measures sum up to 180 degrees, now we can simply say that these two are supplementary angles by the definition of supplementary angles. So 3 and 8 are supplementary. Okay. Now, here's very good advice that I know you're going to laugh at this, but I have students every year, at least 2 students in every class do this. Once you get to exactly what you're trying to prove, stop. Stop proving things. Okay. I have about 2 students in every class of every year that they get to what they're trying to prove, but they're having so much fun, they just keep going. Okay. Don't keep going. Once you get to exactly what you're trying to prove, stop your proof. Okay, guys, I hope you enjoyed those examples and that new learning. Go ahead and enjoy, have some fun with practicing your proofs. L43 through L46 are all proofs. So enjoy. Thanks, guys. See you in the next video.